This is Exponential Growth and Decay Part 2, and we're going to be focusing on compound interest, which is interest earned on your principal and on previously earned interest. The balance, which we're going to call Y, of an account earning compound interest can be represented by the equation Y equals P times the quantity 1 plus R divided by N to the power N times T, where P represents our principal, the initial amount that we start with, R is our annual interest rate in decimal form, T is time in years, and N is the number of times the interest is going to be compounded per year. So let's say we're opening a savings account and the first thing we're going to put in is $100. That's what we're starting with. That is our principal. Our rate that they're going to give us is 6% annual interest compounded monthly. So 6% is our rate. I need to write it in decimal form, so 0.06, and it's compounded monthly. So in a year we have 12 months, so it's going to be compounded 12 times. So here is our function. Now we can simplify this function a little bit. I can do the 1 plus 0.06 divided by 12, which gives me 1.005. And I kind of like this one. It's pretty easy to put in my calculator when I'm substituting things in for t. Or if you want, you can simplify it a little bit further. I can do the 1.005 to the 12th power, but it's going to give me a very long number, 1.061677811864.5. So the reason I don't like this one as much is because that's going to be a very long number to type into my calculator many times over. So I'd probably use this formula, even though technically this one is more simplified. Now this table shows the balance of a money market account. So we just wrote an equation for a savings account. Now we have a money market account, and we're starting with the same amount, $100. But as the years go on, I see that my money, as each year goes on, is being multiplied by 1.1. So if I want to write an equation for this, I notice this is the exponential pattern. I can do something in the form y equals a times b to the x power. A is my y-intercept, which is 100. I'm starting with $100. B represents what my y's are increasing by, 1.1, to the t power. T is going to be our time in years. So we can use this equation. Now they want us to graph the information about the savings account and the money market account in the same coordinate plane so we can compare them. Well, this one we already have data in a table, so it's a little easier to graph. 0, 100, 1, 110, 2, 121, 3, 133, 10, 4 is 146, 41, and 5 is 161.05. Now I'm going to do the same thing for my savings. Now my savings account, I had to actually go back to my formula, the y equals 100 times 1.005 to the power of 12 times t, and get some data points. So when I plugged in 0, I got 100. When I plugged in 1, I got 106.17, so just look here. Then when I plugged in 2, I got 112.72. When I plugged in 3, I got 119.67. Plugged in 4, I got 127.05. And for the last one, I plugged in 5 and I got 134.89. So when I go to compare these two, I notice that if I put my money in the money market account, it's actually going to increase faster. So both of these start with $100, but if I had to choose somewhere to put my money, I'm going to put it in the money market account. So the money market account is going to increase faster. Which is a positive if I want my money to increase quickly. And who doesn't?